Welcome back to Space and Mystery. Today we're exploring one of the most captivating features in our solar system, planetary rings. While Saturn is the undeniable star with its dazzling ring system, it's not the only planet with rings. In fact, all four of our gas and ice giants have them. So let's dive into the secrets of Saturn's rings and check out what makes the rings of Jupiter, Uranus and Neptune so intriguing. Planetary rings are made up of countless particles orbiting a planet in a thin, flat disk. These particles range in size from tiny dust grains to massive chunks of rock and ice, some as large as a small house. Held in place by the planet's gravity, these particles form a ring system that varies in brightness, thickness and width. Rings may look solid from afar, but they're mostly empty space with particles spread out thinly. The shape, size and number of rings can tell us a lot about the planet's history and environment. When we think of rings, we think of Saturn, and for good reason. Saturn's rings are the largest and most spectacular in our solar system, stretching over 280,000 kilometers in diameter. Yet they're incredibly thin, only about 10 meters thick in some places. Saturn's rings are mostly made of water ice, which reflects sunlight and gives them their bright appearance. Thanks to the Cassini spacecraft, which orbited Saturn for 13 years, we now know Saturn's rings are divided into multiple sections, named with letters A, B, C, and so on. The largest gap between these sections is the Cassini division, a dark gap that separates the brightest rings. But where did these rings come from? There are a couple of leading theories. One idea is that a moon or a comet got too close to Saturn and was torn apart by tidal forces, forming the rings. Another theory is that leftover debris from the planet's formation never fully formed into moons and instead became the rings we see today. Saturn's rings aren't static either. Moons within the rings, called shepherd moons, create gaps and even sculpt ring particles, forming beautiful patterns and waves in the rings. Saturn may steal the show, but Jupiter also has a ring system. Discovered in 1979 by the Voyager 1 spacecraft, Jupiter's rings are faint and difficult to see because they're made mostly of tiny dust particles instead of ice. This dust is thought to come from micrometeorite impacts on Jupiter's inner moons, which kick up dust that settles into rings around the planet. Unlike Saturn's bright, icy rings, Jupiter's are almost invisible and require special imaging techniques to see. This just goes to show that not all ring systems are bright and flashy. Some, like Jupiter's, are subtle and nearly hidden from view. Next up is Uranus, the planet with a unique sideways tilt and a complex ring system. Uranus has 13 known rings, most of which are thin, dark and narrow. The rings are thought to be made of rock and dust rather than ice, giving them a darker appearance. The origins of Uranus's rings are still a mystery. One theory is that they're the remains of moons that were shattered by impacts or tidal forces similar to Saturn's rings. Uranus's rings are also unusual because they contain dense, narrow rings that aren't as spread out as Saturn's or Jupiter's rings. Finally, we have Neptune. Like Uranus, Neptune's rings are faint, dark, and mostly made of dust. Neptune has 5 known rings, and what makes them unique is that they're clumpy. The particles aren't evenly distributed. Instead, the rings have dense arcs or clumps where the dust and rock particles gather. Scientists believe these arcs are stabilized by gravitational interactions with Neptune's moon, Galatea. Without this moon's influence, the rings would likely spread out over time. So why do some planets have rings and others don't? Rings are generally found around the larger gas and ice giants, where strong gravitational forces can trap particles in orbit. Most scientists believe rings form from leftover debris, either from moons that got too close and were torn apart, or from the remnants of the planet's formation. It's possible that smaller planets like Earth, Mars and Venus may have had rings at some point in their history, but they would have been much weaker and likely didn't last long due to weaker gravity and atmospheric drag. Believe it or not, planetary rings may not be forever. In the case of Saturn, scientists believe the rings could be slowly disappearing. Gravity and interactions with Saturn's atmosphere may be pulling ring particles inward, a process that could eventually cause the rings to thin out and vanish in about 100 million years. This process, known as a ring rain, means that Saturn's stunning rings are actually a temporary feature. So we're lucky to be living in a time when we can see them at their most spectacular. To recap, Saturn's rings are the brightest and most complex, made mostly of water ice. Jupiter's rings are faint and dusty, formed by impacts on its moons. Uranus's rings are dark and narrow, while Neptune's rings have unique clumps called arcs. Each ring system is different, reflecting the unique history and environment of its planet. Thanks for joining us on this journey through the ringed giants. If you enjoyed this video, don't forget to hit that like button and subscribe to Space and Mystery for more cosmic content. Which ring system do you think is the most interesting? Let us know in the comments, and as always, keep exploring.